Hello, everybody. For this week's Astronomy in Context video, I wanted to actually make a video about how we define the 24-hour day. This is based on our special topic discussion of how humans define time. And it was just so fascinating, so interesting that I want to go ahead and make that our Astronomy in Context video about where do we come up with the 24-hour day. Now, this is a very abbreviated sort of history and overview of where the 24-hour day comes from. I mean, we're talking about millennia of history all going in to arrive at where we are today. So I'm going to try to give you a brief overview. But before we start, most people think that one day is defined by how long it takes the Earth to rotate exactly one time. And they think, oh, well, that's obviously the day. That's usually what you hear in school. What's weird and maybe a little bit mind blowing for you is that that is not our definition of a 24-hour day. The rotational period of the Earth, how long it takes for it to spin around exactly one time, is 23 hours, 56 minutes, and 4 seconds on average, about 4 minutes shorter. Weird, right? So where does this 24-hour day come from? Well, as you'll learn by watching the lecture module videos, you'll learn about the 4-minute difference between the solar day, defined by noon to noon time, versus the sidereal day, the rotational period of the Earth. But let's just go ahead and stick to the 24-hour day. And ultimately, I want to address the question of, is this coming from like on cosmic high, like we discovered a natural uh, part of the universe that just dictates 24 hours in a day? Or really, is this something that humans just made up? Did we make up this concept of a 24-hour day? And I'll let you make your decisions by the end, although I have a fairly certain conclusion. But let's just go ahead and jump into defining the 24-hour day. To do this, we really have to go all the way back to about the 13th century BCE and even before to really start coming up with and seeing how we get the development of our 24-hour day. And just as a little bit of a primer, since I'm not going to include this large image later, what we're looking at here is a sundial from the 13th century BCE, before the Common Era, sometimes just called BC. So we're talking about quite a while ago. And here is a sundial, and notice that it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 divisions for the day. And then this right here, this is from a tomb. They actually would bury, Egyptians would bury a lot of people in their tombs with maps of the sky that should basically showed their calendar and how they kept time, so the dead would be able to keep time and know what's going on, because this tied into understanding like the start of the flood season for the Nile, which are all very important to the survival and the flourishing of the Egyptian civilization. But I just want you to go ahead and notice that it has pictures of constellations and things like that all over it with all sorts of really, really detailed things. But notice that it has all of these circles that are representing periods of times. And if you were to go look at those and count how many segments there are 24 segments there. So really, we're going to have to come to the Egyptians as the people that established our 24-hour day. All right, let's just go ahead. I forgot to make this full screen. So let's go ahead and bounce into full screen. But to really get there, we have to go into why 24 hours. We really have to start going into how did people keep time and how did people build number systems, because we're going to use a number system to count time. So we have to dive all the way back to the original number systems that people were using, which were base 60 and base 12 number systems, rather than our current base 10 number system, where we use a decimal system to do our counting, which is base 10, which you think is very obvious because, hey, I've got 10 fingers, I can count 10 fingers. Well, if we want to go ahead and back up, if you want to come up with a more useful number system before we had, say, modern arithmetic and decimals and things like that, you wanted something that naturally has easy to understand fractions, then you're going to probably go with a counting system that's either base 12 or base 60. So the Sumerians, and we're talking about 4,500 to about 2000 BCE, and then the Babylonians after them, they used a base number or base 60 number system. This is called a sexagesimal. We use a decimal number system, and is all based on, or the idea is why they're coming up with a base 60 system, is 160 has a whole lot of numbers that go into it. It's easy to make fractions. So what numbers can you divide 60 by and end up with a whole number? Well, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30. So that's a lot of natural fractions without actually having a numerical mathematical system that can handle fractions yet. It's an easy natural way to do fractions. Plus, it really goes with the highest number that humans can count on two hands easily. So we just count digits 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we're like, man, we are super clever on counting. Let's push it a little bit further. Now I'm going to hold up one hand here. And what I'm going to do is I'm going to count. I'm actually going to stop my share. I'm going to count my knuckles. Or if you want to, you can count your segments of your fingers. But I can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 knuckles on these 4 fingers. And I'm using my thumb to count. So on one hand, I can count up to 12. And you might be thinking, oh, that should be a base 12 number system, a duodecimal system, which is what the Egyptians used, but we're going to get there. The Sumerians and Babylonians use base 60. And now you might be making connections. 60, oh, there's 60 seconds in a minute, and there's 60 minutes in an hour. So clearly time has a lot of its roots in a base 60 number system, a sexagesimal number system. But I only got up to 12, but I have another hand. So I could go my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, get to 12, and then I could go, let's keep count of that. Do it again, and then I'd get 5 sets of 12, and 5 times 12 is 60. So just on 2 hands, I can count up to 60. And notice that we're already doing some natural fractions as well. So if I want to do what the fractions of 12 are, I can have one finger is 1 quarter, 2 quarters, 3 quarters, 4 quarters. So each finger is a quarter of the 12. So now you can see that the fractions are naturally working out. So if you wanted to have a number system that's a little bit more useful than being able to just count to 10, you want to be able to count up to a bigger number like 60. Hey, base 60 is a natural thing for how our hands are built. Pretty cool, right? So this is commonly thought to be the origins of a base 60 number system. And you can see that it's very closely connected to a base 12, a duodecimal number system that was used by the ancient Egyptians. And since they're using a number system, or rather their number system is probably reflecting a lot of their mythology of the things that are important, we're going to see that everything's integrated. So 12 is going to pop up a whole lot. Why is 12 so significant to the ancient Egyptians? Well, not only is it a good number system, but there are roughly 12 lunar cycles per year. So you can start to see everything is starting to tie into all these astronomical events that are going on, and it becomes a natural way of keeping time that gets tied into the entire mythology that's going on about how the Nile is flooding things. It all comes together to this really deep, rich cultural history. Okay, so now the Egyptians are going to use a base 12 number system. Let's see what they're doing and how they define time, because they are coming up with our 24-hour day. And no, this is not going to be the end of the video, but this is the original part of the 24-hour day. So what do we have? Here is our Egyptian sundial that has 12 divisions. And what they did is they divided the day hours and the night hours into 2 separate periods of time. There is the daytime and the nighttime, and they're almost considered separate entire realms. They tracked daylight time using these sundials that they invented that had 12 divisions. We might be thinking 12 hours in a day, except we're not going to be using the word hour yet. It's 12 divisions in a day. How do they track time at night? That's a little bit more difficult. And what they did is they had a system of star patterns, or just individual stars or small collections of stars, very similar to our idea of constellations, that they called decans. They had 36 decans, and we're talking about 2100 BCE here. And these are the 36 decans that you could see over the course of a year. So it was a way of basically tracking time, similar to our idea of the zodiac a little bit. So they had 36 decans, which means that any given time of the year, 18 of them, half of them, will be up in the night part of the sky. So you're thinking 18, that's not quite 12, except you have to remember that you can't really see stars right at sunset, and you can't really see stars right at sunrise because, the sky is kind of bright and it's washing out the stars. So it's really hard to identify individual stars or constellations. So out of those 18 decans that would be up every night, each one rising 10 minutes after the other one, then, oh, and you can also see 36 times 10 gives us a 360 degrees. So you see the base 60 number system is coming in here, and 36 is divisible by 12. You can see all this coming up. But again, let's get back. So there are 18 decans that will rise and set on any given night. And they will cycle throughout the year through all 36 of them. Except 3 are lost to the morning twilight, 3 are lost to the evening twilight in general, which gives them 12 decans waiting, and each one would rise about 40 minutes after one another, giving them these 12 decans to mark time at night. So now night is going to be divided into 12 divisions based on their decans. Interesting. Awesome. And of course, this got refined until they eventually just came up with 12-day divisions, 12 night divisions. That sort of became set in stone. Oh, there's 12-day divisions, 12 night divisions. We have a 24-hour cycle, a 24-hour day, except these weren't quite hours yet because we live by what we call equinoctial hours. Our hours are evenly divided. Every hour is the same amount of time. Every hour is 60 minutes. And every minute is 60 seconds. We have to remember, I mean, right now it's winter, our days are short. In the summer, our days are long. And if we're just using 12 divisions for every day, regardless of season, sometimes those divisions are going to be longer than other divisions, than the winter divisions. So summer divisions, one of those 12-hour divisions would be long compared to one of those divisions in the winter. So they're not equal. They're not a fixed amount of time. Our single divisions in the summer are longer than our single divisions in the winter. Now we have to go all the way into the Greeks. So we have Hipparchus. Hipparchus, so now we're about 200 BCE. He proposes that, hey, let's do equal divisions. Let's actually say that let's set something so that it's not changing how many, I have 12 hours every day, but how long each hour is constantly changing. That doesn't make sense to my brain. He says, let's come up with something that's standard. So let's set our 12 divisions of day and our 12 divisions of night based on how long the daylight hours, the nighttime hours are during the equinoxes. 12 hours of daylight, 12 hours of darkness. That defines equinoctial hours. You're like, we got it, 24-hour day, we're there. No. He came up with that idea, but it was not adopted and widely used for centuries to millennia. Which means that for a really, really long time, the majority of human history, people lived with hours being different lengths of time depending on when it was in the year. Could you imagine that? Do you feel like rushed in the winter because your division, your hour is rushing by really fast? In the summer, you're kind of lazy and relaxed because they're really, really long. I just cannot fathom that. Okay, so now let's just go ahead and dive into the origin of the minute and the second. We know where the 24 hours came from Egypt, and then whittling it down, and eventually we'll have the equinoctial thing, so they're even divisions. But where did these words minute and second come from? Why is it base 60? And it comes back to our ancient Greeks, measurements of angles, and base 60 number systems. So we have to go with Eratosthenes, the person that actually used wells to measure the circumference of the earth. So he knew the earth was round, he knew the geometry of the earth, and he used that to set up the first geographic latitude system. We had lines running north-south, except they weren't evenly divided. They went through common places, well-known places like cities. Hipparchus comes along a little bit afterwards, and he refines the latitude system to make it equal angular division. He gives us latitude on Earth with the equator and then moving up and moving degrees north and degrees south. He also comes up with a longitude system. So now we have a latitude longitude system, and notice that they do know that the Earth is round all the way back then. And now we have to wait a little while, and then we have Ptolemy, who basically was cataloging and researching a lot of the stuff that Eratosthenes and Hipparchus was doing. But in his Almagest, he then divides the latitude and longitude, each one of these divisions. So we made 360 degrees of longitude, 360s all the way around in a circle. Divide each one of those into a singular degree, and then he divides, say, that 1 degree of longitude into 60 subdivisions. He first does that. So you have 1/60th of degrees, and then he takes those and divides each one of those subdivisions into 60 sub-subdivisions. Well, the first division of a degree into 60 parts is called, in the Almagest, partes minutae primae, the first minute. This will eventually become the word minutes. The second division of each first minute into 60 equal parts is called partes minutae secundae. I hope I'm doing that justice. Second minute, the second minute, the second division into smaller, minute pieces of a degree. This becomes seconds, which seconds really is the second division, which I just find that like language interlacing amazing and awesome. However, this idea is with angles and is with a geographic system for the Earth. A similar idea was not commonly brought into our time system until the invention of mechanical clocks. And then we go spin around 360 degrees in a clock. Then you'll count the 1 hour will go all the way around. So you have the hour hand as it moves around, and then you can divide that into 60 equal parts. Now you have your minutes, and you divide each minute into 60 equal parts, and you have your seconds, and we have a base 60 number system that gets baked into our time. Thank you, Sumerians and Babylonians. However, that's not how we define the second today. That's an astronomical sort of definition of a time where we sort of whittled it down and is sort of ad hoc to get to where we are. Now we define time by science, and specifically atomic physics. So now we set a standard second, we define a second external to what's happening in the sky, because that's constantly changing, especially over the course of millennia. We define a new standard in 1960 seconds. We're 1967, where we set 1 second equal to 9,192,631,770 cycles of the hyperfine structure energy transition of the 6s electron, sorry that says election there, electron, and cesium-133, the stable isotope of cesium. So here you have the valence electron, the 6s electron. You have the hyperfine structure, which I'm not going to go into those details of quantum mechanics because I want to keep this succinct. But there's a transition, and that transition has a wavelength of about 3.26 centimeters. It's a little bit more, that's cutting off some of the significant digits. But if you translate that to its frequency, you end up with this number right here, hertz, which are inverse seconds. So that gives us our definition of what a second is. Is this many cycles of the hyperfine structure. How many of these crests will pass you every second? Well, you need this many crests. This many crests of this particular electromagnetic wave would pass in exactly 1 second. Weird. So now we have our standard SI definition of a second based on atoms. And from there, we can build, okay, now we have our second, we can build our minutes, we can build our hours, we can build our days, we can build our months, and we can build how long the orbital period of the Earth is. So this definition of a second was made pretty much to satisfy the astronomical definition of the second, which was based off the orbital period of the year. And then you divide it all the way down to our 24-hour day, and we saw a little bit of that. So even though we have this external way where we're counting, where we're looking at something fundamental to a cesium atom, the hyperfine structure of the 6s valence electron, we have an independent definition. But notice that the number of cycles there, that is what's defining the second. So really, we're just making our definition of the second based on the atom fit what our original astronomical definition of our second was, which is really, really close. Differs by like, I think 1 part in 10 to the 19 or something like that. Very, very, very crazy close. So, but we have atomic time now. But it doesn't really matter because I want to take a step back. Because notice, this went all the way back to the Egyptians, where they decided they were going to have 12 divisions for daytime, 12 divisions for nighttime. That comes back to the number systems that were being used. We just decided, humans said we will have 24-hour days. And we've backtracked and made up time based on that. So yeah, we just made up the 24-hour day. And we've provided definitions to fill that out. Whew. All right. So that's what I have for the Astronomy in Context video. I will see you in next week's videos and the next Astronomy in Context video.